Alright, tonight in the continuing saga of the Dirty Mic Pre, I'm basically going to walk through the circuit. I haven't talked about this. This is a very basic circuit. There's nothing fancy here. What I'm going to just do is show the different elements. So the input comes in basically through this circuit here. Let me just get the computer lined up. So we have the basic stuff. Basic is a 48 volt source, and it's going through a switch with an LED on this side. Some 6.8K, which is the normal thing for the XLR input. It goes through this circuit right here, which is basically an impedance adjustment. Now keep in mind I also have an impedance knob on the amplifier, but we'll get to that. This is just your basic pad. Sorry, not basic pad, it's your basic impedance switch. So I'll create a low impedance input to roll off some of the high end of your mic output. And that's kind of what you'd see in a loaded input stage, basically, is what it means. It's a nice little effect. It works good. Some people love it for the SM57. It kind of mellows it out a bit. The next part of this circuit here is the pad switch. It's just a 20 dB pad, so 619 and 169 is the numbers I used, and it's just a differential pad is all it is. Very simple. You can use whatever values you like. I chose those ones. Again, doesn't really matter. Obviously you want lower resistance means lower thermal noise. That's why those values are so low, but it also increases the current. So there you go. I wouldn't recommend going much above like into the kilo ohms, because then you're going to start to get into some noise issues, and especially on your input, which is a low signal. You want to be careful there. But this does cause some loading. I find it to work okay. And the next one is something I wouldn't recommend doing, but that's one of the things I did on this original board. I flipped the polarity on the input. Luckily enough, my amplifier circuit that I've got here is okay with that. But a word of caution: whenever you flip an input polarity going into the amplifier, if your amplifier is at all unstable, it's possibly going to cause it to oscillate, or worse, rail. So it's something you want to watch out for. And then of course I go through a transformer, and the transformer that we're talking about here is this Hammond. It's an 804E. Now here's where it gets tricky, because this is almost a 1-to-1 ratio transformer. Obviously if I could have an advantage of a higher turns ratio, so like a 1-to-20, it would be a much better circuit. But I make up for that with my amplifier gain stage. Now, the amplifier in this circuit is very straightforward. So the whole point of this exercise is to test out those transformers and see what they sound like. I kind of get a sense, because I swept them on the oscilloscope with the function generator, of where their problem areas are, and it's typically in the low end. However, I just want to try it. So there's my over voltage protection. Some diode bridges there that will shunt off any low transients or high transients, and I'll put them right to the rails. So that basically takes care of ESD protection more than anything. And then R9 in this schematic is drawn as a simple 150K resistor. That is essentially the overall input impedance of this amplifier, because I've got a super high impedance amplifier here, a fantastically great op amp, ridiculously overpriced op amp, the OPA 627, but it's a great amplifier. So what I've done is I put a pot right there, and I can play around with that. So why did I put a pot there? I want to play around with the actual transformer, and this will allow me to match powers a little bit by dialing down that value. I'm sure it'll cause all kinds of instabilities, but we're going to find out what it does. This amplifier has been remarkably stable. I've used this in a few different designs, not only audio but other things. It's a great fast amplifier, and it's configured as a simple non-inverting amplifier. I've got a pot value on there of actually 100K, and I think I put a 10 and a 1K, so I can make up a little bit of gain there, 110 gain on it, to compensate for the transformer's lack of gain. That basically, I think it gives me a 50 dB or 60 or 55 dB gain. I'm not sure, I can't remember. I'd have to calculate it. The trim pot here is just a simple 100K, and it's to help the balance when you put a DC signal on the input. You can balance it off your rejection ratio. The OP627 has it. Sorry, 627 has it. So I always populate it, use it well. It works good. But again, it's a very good op amp. I've got a couple of these Jensen JT-OLI 3s or whatever we call them here, and they're just wound inductors. They give a little bit of resistance, approximately 39 R to 3.7 microhenries, and they pretty much work as the way I've drawn them. They worked really good in another design, so I just kind of threw them in here because I had them, so they're used. And then the output transformer, again, is going to be one of these bad boys. Again, 1-to-1 should be just fine here. I might find that I have to change my input and transformer. I don't know, but that's what we're playing with right now. So tonight, that's the circuit. The power supply is a little bit more complicated than that, so I won't get into that. But that's a power supply that I designed for another circuit, and it's pretty good. It's got plus and minus 18. And plus and minus, plus 48 volts, and they're all completely tunable. So I think the range is down from 12 up to 25 on one, and the other side is 48 is down to 30 and up to 60. So that's the swing range on them. It's a very good supply. It's got TVS and GSA's gas surge arresters. So we got quick and slow transient absorption on the front end, and it's a discrete rectifier, which for me it's a discrete rectifier for each circuit there. So I like discretes. I'm not a bridge guy. I find the heat dissipation's better. 2 monster toroidal transformers on the back, PCB mount. Got quite a bit of heft to it, and then you look at it's just linear regs, but there's a whole lot of capacitive filtering there. So there's some major box storage happening here. It works great. It's very quiet, very clean, low noise power supply. So that's the board, and here's the little prototype board for the simple op amp amplifier. There's your Jensen wound inductors. I've got some serious capacitance on the board that just gives me some bulk storage. Yeah, and I didn't mention the feedback cap. I've got a 0.3 on there. That picofarad, that will tame some of the high end of this guy a little bit. You can go a little bit heftier on that if you want, maybe 0.8 or something pico. But there you go. That's as simple as that. All the cables are done now. I finished the braided cable for the power switch. All the switches are wired up. It's ready to go. So I just gotta finish drilling some holes and box it up. And that's it for now.